to the Truth in My Days podcast, where we defend the Word of God against the challenges of men.
Hi, I'm Dana Torst, and welcome to another episode of the Truth in My Days radio program. Today, I'm here with John Torst and Jason Chan as they discuss the important topic of creation and evolution. We are continuing from the previous episode. We hope you enjoy.
Okay, is there even more?
There is indeed. We're back to carbon-14 again.
Okay.
And once again, we're not giving specific dates, as they try to do with carbon dating. We're simply pointing out maximum possibilities.
Okay.
Now, the half-life, we've mentioned this before, the half-life of carbon-14 is only 5,730 years. Okay. Some radioactive substances that are like partial seconds. So to them, this is pretty old, but other ones are in the order of billions of years.
Okay.
So the half-life is 5,730 years, and you remember half-life means that in that period of time, half of it decays away. Mm-hmm. So after the next half-life, two half-lives, half of the half has gone, so you're left with a quarter. After another half-life, you're left with an eighth.
Yep.
After 10 half-lives, and less than 1/1000th is left.
Okay.
What that means is if you took a lump of pure carbon-14, as massive as the Earth itself, it would all have decayed away in less than 1 million years. You'd have none left. Less than 1 million years. Okay. So if, and that's if you start with a sample the size of the Earth.
Right.
When we're looking at carbon-14 in fossils,
Yeah.
that's much less than the size of the Earth. It'd be a lot faster. So certainly, if a sample were really over 1 million years old, you'd have no carbon-14 left in it all, no radiocarbon. That's not what we find. Coal, for example, which supposedly formed all these tens of millions of years ago, all over the world, wherever you get it from, it has carbon-14 in it, which means that these are well less than 1 million years. Oh, much less. They were thousands of years old at most.
How do evolutionists explain this one?
Oh, well, they will go to the dodge of contamination. Contamination, you see, it's the carbon-14 wasn't really in the fossil. The stupid researcher actually contaminated the sample. He put some carbon-14 on it from his own body or from
his
the atmosphere or whatever. And you can find every single coal sample from every single field in the world, doesn't matter. Contamination. Where's your proof that's contamination? Well, they can't prove it. They just assume it because it has to be. Because we know these coal samples must be hundreds of millions of years old or tens of millions of years old. So it has to be contamination. Now, they can be handled as well as possible, and they'll still insist it's contamination, which should call the whole method into question, but it never does. You see, it's always the double standard. We champion it when we can use it to support our view. When it debunks our view, then we attack it. But that's what they do. It's all contamination, but they get checkmated eventually with diamonds. What do we know about diamonds?
They're one of the hardest substances on Earth. They're made of carbon.
The hardest?
The hardest.
Actually, you're right the first time as well.
Oh, okay.
For a very, very long time, it was the hardest substance known.
I see.
It was so hard that when rocks are graded in minerals, it's called Mohs hardness scale.
Yep.
And they go 1 to 10. And the hardest would be diamond number 1, and second is corundum, and then you get down to number 10, it's talc.
Right, very crumbly,
Very crumbly. But the difference in hardness between diamond number 1 and corundum number 2 is actually bigger than the difference between corundum number 2 and talc number 10.
Wow.
It's such a strong, rigid structure, diamonds do.
Yep.
They've actually, within the last, I think, 10 or 15 years, discovered a new form of carbon called graphene, which is actually harder than diamond, but that's a very new discovery.
Yeah, there's lots of engineering hope that people are putting into graphene. But anyways.
Be careful. Apparently it flakes kind of like asbestos, not to the same extent, but it does. So when people use it in masks, for example, you may as well be breathing in asbestos. So it's hard, and here's the problem. How do you contaminate a diamond? To contaminate a diamond with carbon-14, you would actually have to knock one of the carbon-12 atoms out of its structure and replace it. But how do you do that when it's the hardest substance there is?
I have no idea.
Can't be done. So you can claim it for coal or graphite. You cannot do it with diamonds. Okay? It's very resistant to contamination. Now, according to evolutionists, the diamonds formed 1 to 3 billion years ago. A geophysicist named Dr. John Baumgartner, part of this rate research group, investigated carbon-14 in a number of diamonds. And remember, there should be no carbon-14 at all if they really were over 1 billion years old. But the radiocarbon lab reported that there was over 10 times the detection limit.
I see.
So actually much less than 1 million years old. And Baumgartner went ahead and repeated this with 6 more alluvial diamonds from Namibia. All of these had even more radiocarbon in it. So here you go, folks. There is hard scientific evidence, a lot of different areas, a lot of different ways to prove that the Earth is of an age consistent with the biblical timeline, a maximum of 7,686 years. You're told that there's overwhelming scientific evidence that the Earth is so old. We have so many different ways to know. We really don't. There's this very, very few things they appeal to try to prove it. And all of them, as we've seen, are problematic, seriously problematic. There's only one left, really, one issue to look at on this. And this, unfortunately, is the one that has managed to convince a lot of Christians to abandon the biblical timeline. And that is hugely problematic. Do you know what this issue would be?
About stars and the age of stars in our universe?
Exactly.
Okay.
The stars, the starlight problem.
Okay.
And it goes like this. Okay? And this will be the most common objection you will encounter to the age of the young universe.
Okay.
We know how far stars are away from Earth. We know how fast light travels.
Right, yep.
3.0 times 10 to the 8 meters per second.
Yep.
We know how, and that's the maximum speed. Light cannot move faster than that.
Yeah, that's the speed in a vacuum, yes.
Yes. So we know, since we can see the star, and so the light must have gone to us all the way from that star at that speed. And if the star is billions of light years away, then the light must have traveled billions of years. And so the world must be billions of years old. Have you heard that objection before?
I haven't heard of it before, but it makes sense assuming that these distances are correctly measured.
Assuming that the distances are correctly measured, that's true. That's an interesting discussion. But before we even get into that, let me point out something else that people may not know.
Okay.
And that is, this is assuming light can and has always and only traveled at that maximum speed. The Big Bang Theory, the one that scientists tell us this is the scientific view, has the very same problem, a light travel time problem. And the problem basically goes like this. The temperature throughout the entire background of the universe, okay, we use the COBE satellites to come with those measurements in 1992. COBE, so COBE for Cosmic Background Explorer satellite, and brought in the best data we had so far on the temperature of the Earth. And they found that the universe, everywhere you look, it's isothermal. It's the same temperature everywhere. Now, again, you know from physics about heat transfer, right? When heat moves, where does it move from and where does it move to?
Yeah, it moves from the hotter end to the lower end.
Exactly. It always moves from hotter to colder.
Yes.
And we'll keep doing that until the temperature equalizes.
Yep.
Okay? The only way you can go against that is artificially with a heat pump or something like that. But,
Right.
But naturally, heat always moves from hotter to colder. So the hotter object becomes colder, the colder object becomes hotter until they match,
Right.
and you get no more heat transfer. That's actually the heat death of the universe we're heading towards. But here's the thing. The temperature, everywhere you look in the universe, no matter how far out, it's all about equal. And the only way that could have happened is for the radiation to have traveled from the hotter spots to the colder spots until everything reaches equilibrium.
Yeah, that sounds right.
But because it's equilibrium everywhere, you would have to have light traveling from one end of the cosmos all the way to the other to do the equalization.
Right.
And heat cannot move faster than light.
Yeah.
And supposedly, science has proven the universe is 13.6 billion years old. That's the Big Bang timescale. But the spread of the universe is 93 billion light years. So how do you cross 93 billion light years of distance in 13.6 billion years?
I have no clue.
We can't unless light has gotten from point A to point B faster than the speed of light alone allows. So we may not know the mechanism of how it can happen, but it has to happen regardless of whether you take the biblical model or the Big Bang model. Okay? Now, they never want this called the horizon problem. They never want to talk about that. They want to go after the biblical model, say, oh, look, light can't have traveled faster than the speed of light. Your model must be wrong. Huh. They don't mention that you have the same problem with their model. Okay, that's okay. And yet, so many Christians jump all over the Big Bang bandwagon. Not sure why.
Okay. We
can also point out, by the way, in passing, that it's impossible to measure the one-way speed of light. We don't know.
Yeah, that is true.
Can you elaborate on that?
Yeah, because the way that we're measuring the speed of light right now is that we have to shoot a beam of light into a mirror and have that reflect back. So that's the only way that we can measure the speed of light, because we need a point in space where we can start and stop this experiment. And that is not possible to do if we were to just set up a one-way experiment to measure the speed of light.
Exactly. Very good. So yeah, you cannot measure. Every measurement we've ever done of the speed of light is always two-way.
Yep.
It's the time to get there and then the time to bounce back. Mm-hmm. Okay? And then we calculate the maximum speed of light by dividing that by 2, basically, assuming that it goes at the same speed both ways. But we don't know that.
Yeah, we don't.
There are asymmetries in the universe, like the matter-antimatter, for example. Yep. Well, this matter, and where's the antimatter? Mm-hmm. So there are asymmetries. It's entirely possible that the light coming here from the stars is moving at essentially instantaneously or near instantaneously. And then when it hits something and bounces back, it moves at half the speed of light that we measure.
Possibly, yeah.
Yeah, so we don't know for sure. Yeah. When we say that the light is coming from the stars to us at 3.0 times 10 to the 8 meters per second, maybe, but we don't know that. Right. Maybe it's reaching us instantaneously and we're seeing what's out there exactly as it's happening. Mm-hmm. That is a possibility.
Okay.
So that's to set the stage and to point out that this, if this is a problem for us, it's certainly a problem for them.
I see.
So what are the possible explanations there? Well, one of them is that the speed of light may not have been constant throughout history. It may have been faster in the past. There's a lot of resistance to that idea because of Einstein's theory of relativity, which makes speed of light the fastest possible speed it can have, 2.9997 meters per second. It's the maximum possible. Now, that's a theory. It's a thought experiment. It's supposed to be supported by some experimental results, cast doubt on by some other experimental results. But as far as I know, it's constant with respect to space, not necessarily with respect to time. Like the maximum speed might have been different in the past. And certainly there's some observational evidence that supports that idea. Some years back, for example, this cover of Science... Discover magazine cover articles, was Einstein wrong about the speed of light? That I think was the April 2003 issue. And what was found, why this became an issue, is observations done by a team of scientists, Australian scientists.
Thank you everyone for listening today. Unfortunately, we have run out of time, but please join us for the next part tomorrow. Same time and same place. If you enjoy our content and think this is important material, the best compliment you can pay is by sharing this with your friends and family. This helps us out a lot. Also, if you enjoyed today's program, please like, comment, share, and subscribe to this podcast. We would love to hear from you. Thank you for listening to the Truth in My Days podcast with John Torse. We would love to hear from you. Please feel free to share any questions or comments you may have. You can reach us on Facebook, Instagram, MeWe, and YouTube. Simply search Truth in My Days as one word. Again, Truth in My Days as one word, no spaces in between. And you can connect with us. You may also visit our website for more comprehensive material and to learn more about our ministry. Our website is truthinmydays.com. Thank you.